Hey guys, so in this lecture, in the first video, we're gonna more practice for the complex circuit, and then we're gonna move to start in chapter 24, talking about the magnetic field. Okay, let's start with the first example here for more practice for a circuit or for the complex circuit. And in particular, we just more practice for the three steps or the general strategy to solve the circuit: reduce and reuse and recycle. Again, we have three circuits here, our three resistors connected with the one single source. And we're asking to fill that table here by finding the difference potential across the three resistors and the current through each resistor. So again, we're gonna use our concept to reduce. So we're gonna start to reduce our circuit. Here is the first step, called reduce. So basically, I'm gonna take those two resistors together, and I call this one is the 1/R equivalent. Basically 1/10 ohm plus 1/15 ohm, and this one will be 1/6 equal 1/6 ohm. So from here, we end up with our resistors, our R equivalent here. We call it equivalent resistor equal 6 ohm. Now I want to draw my resistors in a new shape or after the reductions. It's basically this the voltage source connected with the R equivalent, 6 ohm, and connected to the 5 ohm resistors. So here's the R equivalent, 6 ohm, and here's the 5 ohm resistors, and here's our source, 10 volt. Okay, so now that after we reduce, we enough for reduction. So from here, I can move for the second step, which reuse. So basically, I need to find my I totals. How I can find that I total? Where is the I total? Is that the current go or through our circuit. Here is the I total. So this basically we're gonna go through this path. So we're gonna apply the Kirchhoff voltage law. I start here 10 volt minus the current here I total times R equivalent 6 ohm. Here is the I total times 6 ohm. And then here's the voltage difference through the 5 ohm will be I total times 5 ohm. This is the entire algebraic equals 0. So from here, I can find my I total, well, 10 volt. And here's the 5 plus 6 will be 11 ohm. I have 10 divided by 11 amps. And if you can find this one is the close to the 0.91 amps. Now I am done with the reuse. I reuse the equivalent circuit to find my total using Kirchhoff law to find my total current. Now we're gonna move for the third step, which recycle. I have to go in reverse. Recycle. So go in the reverse. That means I go with this circuit here. I go back for my circuit. So let's assume this one is the I15. Go in this part. And here is the I, call it I10. Okay. So we can find the delta V, or I can use this loop here and to apply the Kirchhoff voltage law. Sorry for this confusion. I wanted to draw the loop, this case here. So here is the delta Vs, which means my source, or my voltage source. I want to type it. I write down the Kirchhoff law, 10 volt minus, I have here is 10 times I10. So here is the I10 times 10 ohm. Minus, I'm talking about here, in this branch here, is still my I total. It's not I10. So here is gonna be I total times 5 ohm. And this is summation equals 0. Where is the I total here? It is 0.91 amps. So in this equations here, I can find my I10, or the current through the resistors, 10 ohm. It will be 10 minus, here is the 5, minus 5 ohms times 0.9 amps divided by 10. 10 ohm. So we end up with the point, if my calculation is right, 0.55 amps. And make sure it should be less than 0.9, because here's my I totals, and I totals go to the two branches, go to the through 10 ohms and go to the through 15 ohms. Again, most of the current goes through the lower resistors. So we find the current through the 10 ohms, 0.55. Logically, we expect it when we calculate the voltage across 15 amps, it should be less than that value, less than 0.55. So let's then gonna do it the same thing. Let's change the color for the pen and apply the Kirchhoff law in that loop. So I go include this one here, and I go to the 15, and I go to this path, and I close this path. So Kirchhoff law again, here is will be 10 volt minus what I have here, I15 times 15, I15 times 15 ohms minus, and go to this path here, again will be I total times 5 ohm equals 0. So from here, I can find I15 in that case will be equal, here is the 15, 10 minus 15 ohm times 0.9 amps divided by, here's a 5, not 15, sorry, divided by 50. And this one end up with a 0.36 amps. So basically, we confirm our value should be less than 0.55 amps. So now I can find my voltage difference, or voltage potentials. Let's call it, here is the 5 and 10 and 15. So here is the delta V in 5 volts, in 5 ohms, 5. Okay, which will be I total times 5. Okay, so I total times 5. It should be, will be 0.9 times 5. Okay, here is the amp and here is the ohm. Here's the close to the 4.5 volt. This is the voltage across R or the 5 ohms resistors. Here's the delta V in the 10 resistors and the 10 resistors. It will be 10 ohms times I10 times I10. I have 10 amps, 10 ohms times I10. Where is the I10? 0.55. 0.55 amps. I end up with this one will be 5.5 volt. The last voltage, delta V 15. So before I confirm my calculations here, I noticed that 10 and 15, they are connected in parallel. When we have the connection in parallel, the voltage, it should be equal. Okay, so I have to find it 5.5 volt. So let's confirm that. It's gonna be 15 ohms times I15, which 15 ohms times 0.36 amp. So in this one it should be 5.5 volt. So I get that back. And another two confirmations for this circuit here. Here's the voltage. We found it 5.5. Here's the 4.5. Add them together, you end up with my delta V. Okay, so if you want to write it down just to confirm, here is the delta V, my source, it's equal 10. It should be equal my delta V5 plus my delta V in my equivalent circuit. It will be confirmed the same thing. So now we can fill out our tables here. Delta V across this one is 0.45 volt, and here is the 5.5 volt. Here is the 5.5 volt. Here is the I in cross 5 volt equal I totals will be 0.9 amps, and here's the across this one will be 0.5. How much I found the current? Yes, 0.55 amps, and here it should be 0.36 amps. Okay. So that's the solution for this problem. I end up with this video and see you next video regarding to the chapter 24. Thank you so much.